400 million miles from Earth is a hulking giant of a planet, with a mass more than twice that of all the 8 other planets lumped together. It rotates in less than 10 hours, faster than any other planet, and its markings sweep across its face in a single evening, creating distinct changes in a matter of a few minutes. Jupiter has more than 11 times Earth's diameter, 300 times the mass, and 1,300 times the volume. As it ponderously circles the sun once every 12 Earth years, it pulls with it 13 known satellites. Its clouded atmosphere is striped by vast, shifting, multicolored bands. In fact, all that we can see of this giant, even during the close encounters by the Voyager spacecraft, are huge, turbulent clouds of gas, mostly hydrogen and helium. Even the Great Red Spot, 3 times the width of Earth, has been found to be a sea of whirling gas clouds. Once man learned to break free of Earth's gravity, he reached out to those wandering worlds in space called planets. The highly successful Viking project landed 2 unmanned scientific stations on the surface of Mars. And now the exciting Voyager project, with its 2 advanced Mariner-class spacecraft, is making an extensive study of Jupiter and its satellites before moving rapidly on its way to uncover the mysteries of Saturn. Each spacecraft weighs 1,753 pounds, and the large boom seen extending downward to its right is a 43-foot-long magnetometer housing magnetic field instruments. A closer view of the Voyager spacecraft is seen here at the Jet Propulsion Laboratory in Pasadena, California, that manages the Voyager project for the National Aeronautics and Space Administration. Here, minus its magnetometer, the major feature of the spacecraft is its 12-foot dish antenna for communications with Earth. It is attached to a 10-sided base which contains electronics, computers, radios, tape recorders, etc. Most of the 11 scientific instruments, including cameras, are attached to the boom on the right, with optical instruments mounted on a movable platform. The 2 whip antennas are used for radio astronomy and plasma wave experiments. To the left of the base, on another boom, are 3 nuclear power generators, which supply the electricity. 2 Voyager spacecraft were launched by NASA aboard Titan IIIe Centaur launch vehicles from Cape Canaveral, Florida, on August 20th and September 5th, 1977. Voyager 1, launched on the later date, flew a faster, shorter route and reached Jupiter 4 months ahead of Voyager 2. The Voyagers are the fastest man-made objects ever to leave Earth. When the final rocket stage cut off to end powered flight, each spacecraft was traveling at more than 32,000 miles per hour, or almost 9 miles per second. In less than 10 hours, they had crossed the moon's orbit. This picture of a crescent-shaped Earth and moon, the first of its kind ever taken by a spacecraft, was recorded 2 weeks after launch by Voyager 1, when it was 7.2 million miles from Earth. The moon is at the top of the picture and beyond Earth. Voyager 1 was directly above Mount Everest. So what we can see on Earth are Eastern Asia, the Western Pacific Ocean, and part of the Arctic. Because Earth is many times brighter, the moon was artificially brightened by computer enhancement so that both bodies would show clearly in the prints. Both Voyagers spent more than 9 months crossing the asteroid belt, a vast no-man's land of space debris that circles the sun between the orbits of Mars and Jupiter. They are the 3rd and 4th spacecraft to make such a crossing. The other 2 were Pioneer 10 in 1973 and Pioneer 11 in 1974. Here, a Voyager spacecraft aims its instrument scan platform at Jupiter in this painting depicting a major step in the mission. Voyager 1's cameras captured 2 of Jupiter's moons, Ganymede in the center to the right of the planet, and Europa at the top right of your screen, from a distance of 29 million miles. Despite the small images of the moons, this photo and others are beginning to show details on the satellites not seen before in photos from Earth. The bright zone stretching across the northern hemisphere of Jupiter may be clouds of frozen ammonia, similar to cirrus clouds of water ice in Earth's atmosphere. At a range of 20 million miles, Voyager took this impressive photo of Jupiter. Objects as small as 375 miles across can now be seen. Voyager scientists now observe that different colors in the clouds around the Great Red Spot imply that the clouds swirl around the spot in varying altitudes. They also see apparently regular spacing between the small white spots in the southern hemisphere and similar positioning of the dark spots in the northern hemisphere. The bright cloud in the equatorial region north of the Great Red Spot appears to be where bright clouds originate, then stream westward. Jupiter's satellite Io poses before the giant planet from a distance of 29 million miles. The satellite's shadow can be seen falling on the face of Jupiter at the left of the picture. Io is traveling from left to right in its 1 3/4 day orbit around Jupiter. Even from this great distance, the image of Io shows dark poles and a bright equatorial region. On top of Jupiter's brightly colored cloud patterns is the shadow of Ganymede, the largest of the Jovian satellites. Io, the innermost of the Galilean satellites, is visible to the right of Jupiter. Io has been found to be the most volcanically active body so far discovered in the solar system. Voyager 2 obtained this picture from a range of about 15 million miles. Jupiter is about 12.4 million miles from the spacecraft when Voyager 1 took this photo of the planet and 2 of its satellites. Io is about 220,000 miles above the Great Red Spot to the left of the screen, while Europa is about 375,000 miles above Jupiter's clouds. Although these 2 satellites have the same brightness, Io's color differs greatly from that of Europa. There is evidence in this photo of circular motion in Jupiter's atmosphere. While the dominant movement is west to east, small-scale movement within and between the bands includes eddy-like circulation. This color composite made from Voyager 2's narrow-angle camera frame shows the Great Red Spot during the late Jovian afternoon. North of the red spot lies a curious darker section of the south equatorial belt, the belt in which the Great Red Spot is located. To the lower left of this famous feature lies one of 3 long-lived white ovals. This photograph was taken when Voyager 2 was nearly 6 million miles from Jupiter. The smallest features visible are over 106 miles across. Voyager 2 was rapidly nearing the giant planet when it sent this photograph back to Earth from a distance of 8 million miles. Seen in front of the turbulent clouds is the satellite Io, whose size approximates that of our moon. The red, orange, and yellow colors of Io are thought to be deposits of sulfur and sulfur compounds produced by the satellite's volcanic eruptions. The smallest features that can be distinguished in this photo are about 125 miles across. This dramatic view of Jupiter's Great Red Spot and its surroundings was obtained when Voyager 1 was 5.7 million miles from the planet. Cloud details as small as 100 miles across can be seen in this photograph. The colorful wavy cloud pattern to the left of the Great Red Spot is a region of extraordinarily complex and variable wave motion. Voyager 2 transmitted this image showing the region of Jupiter extending from the equator to the southern polar latitudes in the vicinity of the Great Red Spot. A white oval, different from the one observed in a similar position at the time of the Voyager 1 encounter, is situated south of the Great Red Spot. The region of white clouds now extends from east of the Great Red Spot and around its northern boundary, preventing small cloud vortices from circling the feature. The photo was taken from a distance of 3.72 million miles. Another view of the Great Red Spot taken by Voyager 2 3 days later and very near its closest encounter with Jupiter shows the white cloud along its northern boundary even more noticeably. A closer view of the white oval cloud is also presented. Despite the dramatic difference in color, the internal structure of these spots seems identical. Since they both rotate in a counterclockwise or anticyclonic manner, these observations indicate that they are meteorologically similar. 4 months separate these photos of Jupiter and show that the planet's atmosphere undergoes constant change, presenting an ever-shifting face to observers. The photo on the left was taken by Voyager 1 and the one on the right by Voyager 2, when both spacecraft were about the same distance from the giant planet. important changes appear in the region of the Great Red Spot. One of the white ovals, located to the southwest of it, has drifted 60 degrees eastward around the planet, allowing another feature just to the west of the oval in the Voyager 1 photo to move directly beneath the red spot. The bright tongue, which extends upward from the red spot, is interacting with a thin, bright cloud above it that has traveled twice around Jupiter in the 4-month period. The only feature in the Voyager 2 photo not observed by Voyager 1 is a dark brown spot that has developed along the north edge of the brown equatorial region. Ganymede is visible at the bottom of the Voyager 1 photo. Here is another spectacular close view of the Great Red Spot and its turbulent surroundings taken by Voyager 1. Although the color is highly exaggerated and tends to emphasize red and blue at the expense of green, note the wealth of detail within both the Great Red Spot and the white oval, as well as in the churning clouds that flow around them. The distance from top to bottom is 15,000 miles. The smallest features visible are about 20 miles across. Here we see cylindrical projections of Jupiter, representing both Voyager 1 at the top and Voyager 2 beneath. A comparison between the pictures shows the relative motions of features in the planet's atmosphere. It can be seen, for example, that the Great Red Spot has moved westward and the white oval features eastward during the 4 months between the acquisition of these projections. Jet Propulsion Laboratory's Image Processing Lab constructed this photo of the northern hemisphere of Jupiter as seen from directly above its north pole. Even though the belt zone appearance of the planet becomes less apparent at higher latitudes, cloud features still seem to be zonally positioned. It is interesting to note that many of the cloud plumes close to the planet's equator are evenly spaced, and that the active cloud plumes marked by the bright spots are not symmetrical. The broad white region is divided by the North Temperate Belt's high-speed jet stream, seen in this photo as a thin brown line. The fact that Jupiter has a ring was uncovered by Voyager 1 on March 4, 1979. Comprised of dark particles, the ring is no more than 18 miles thick, and probably much less. It is not an easily identifiable feature of Jupiter, being only 3.5 times brighter than the faintest star visible to the naked eye. This view is an artist's conception. The unexpected brightness of this striking view of Jupiter's ring is probably due to forward scattering of sunlight by small ring particles. Seen within the inner edge of the brighter ring is a fainter ring, which may extend all the way down to Jupiter's cloud tops. Voyager 2 recorded this photograph from the dark side of the planet. From a range of 900,000 miles, Voyager 2 recorded this color composite. The ring system is shown as 2 light orange lines protruding from the left toward Jupiter's limb. The picture was taken in Jupiter's shadow through orange and violet filters. The colorful images of the planet's bright limb are evidence of the spacecraft motion during the long exposures. The lower ring image was cut short by Jupiter's shadow on the ring. Jupiter has 13 known satellites. The 4 largest were discovered by the first man to aim a telescope at the planet, Galileo Galilei, in 1609 and 1610. His discovery that Jupiter has satellites provided evidence that the Copernican theory of the solar system was correct and that Earth is not the center. The 4 satellites discovered by Galileo, the largest in Jupiter's mini-solar system, are Io, Europa, Ganymede, and Callisto. Together, they are called the Galilean satellites, and their size compared to the planet Mercury and our moon can be clearly seen on this diagram. In addition to the 4 Galilean satellites, Voyager 1 was able to photograph tiny red Amalthea, discovered only 87 years ago. Too small ever to have been round, it has a long history of impact cratering, and its red color may be a surface coating. The innermost of Jupiter's known satellites, it whizzes around the planet every 12 hours, only about 69,000 miles from the cloud tops, outside the newly discovered ring. Amalthea appears to be about 80 miles high by 105 miles wide. The largest of the Galilean satellites, Ganymede, was photographed by Voyager 2 at a distance of 756,000 miles. The photo shows a large, dark, circular feature with narrow, closely spaced light bands traversing its surface. The bright spots dotting the surface are relatively recent impact craters, while lighter circular areas may be older impact areas. Showing the southwestern limb region of Ganymede, this photo was taken from a distance of only 151,800 miles by Voyager 1, which means that the smallest features visible are about 1.5 miles across. The surface shows numerous impact craters, many of which have extensive bright ray systems. Light bands traversing the surface contain alternating bright and dark lines, which probably represent deformation of the icy central material. Another, still closer look at Ganymede by Voyager 2 from 62,000 miles out. It shows numerous impact craters, many with bright ray systems. At the bottom, portions of grooved terrain transect other portions, which indicate that they are younger. The dark patches of heavily cratered terrain at the right center of your screen are probably ancient icy material formed prior to the grooved terrain. The large rayed crater at the upper center is about 93 miles in diameter. Jupiter's satellite Callisto is seen here by Voyager 2 from a distance of about 1.5 million miles. Callisto is covered with bright spots which are meteorite impact craters. Scientists believe that heavily cratered terrains like those on Callisto are indicative of ancient planetary surfaces. This photo of Callisto was taken by Voyager 1 from a distance of 217,000 miles. Smaller than Ganymede and about the size of the planet Mercury, Callisto is apparently composed of a mixture of ice and rock. Far more craters appear on the surface of Callisto than on that of Ganymede, leading scientists to believe that Callisto is the oldest of the Galilean satellites, possibly dating back to 4 or 4.5 billion years ago. 9 different frames were used to make up this photo mosaic of Callisto taken by Voyager 2 at a range of 245,000 miles. About 15 concentric rings surround the bright central spot. Many hundreds of moderate-sized impacts are also seen, a few with bright radial ray patterns. The limb is very smooth, confirming that no high topography has been seen on the satellite, an observation consistent with its icy composition. Voyager 2 recorded this view of Jupiter's satellite Europa at a distance of 756,000 miles. Detail of about 12.6 miles across is clearly seen. The color reconstruction in this image was slightly enhanced to bring out detail in the complicated mottled region on the west limb. This region contains some of the linear fracture-like features discovered earlier by Voyager 1. The regions in the north and south polar areas, which appear bluish in this version, are in fact white. Europa, the size of our moon, is thought to have a crust of ice perhaps 63 miles thick, which overlies the silicate crust. The complex array of streaks indicate the crust has been fractured and filled by materials from the interior. The lack of relief, that is, any visible mountains or craters on its bright limb, is consistent with a thick ice crust. In contrast to its icy neighbors, Ganymede and Callisto, Europa has very few impact craters. The relative absence of features and low topography suggests the crust is young and warm beneath its icy surface. This image, like the one just seen, was acquired by Voyager 2 during its close encounter with Europa from a range of about 152,000 miles. This, the brightest of the Galilean satellites, has a density that suggests it has a substantial quantity of water. The tectonic pattern seen on its surface differs drastically from the fault system seen on Ganymede, where pieces of the crust have moved relative to each other. On Europa, the crust evidently fractures, but the pieces remain roughly in their original position. Jupiter's closest Galilean satellite, Io, is the first body in the solar system, with the exception of our own planet Earth, where active volcanism has been observed. This full disk image of Io, recorded by Voyager 1 from a distance of 543,000 miles, shows a variety of features that appear linked to the satellite's intense volcanic activity. The circular donut-shaped feature in the center has been identified with a known erupting volcano, and similar features can be seen spread across the face of the satellite. Of all the satellites, Io generated the most excitement in the scientific community. As Voyager 1 closed in on Io, the puzzle was why its surface, so cratered and pocked from a distance, began to look smoother and younger as the spacecraft neared. The mystery was solved with the discovery of active volcanoes spewing sulfur 100 miles high and showering it down on the crust, obliterating the old surface. The reddish, white, and black areas are probably surface deposits, possibly consisting of salt, sulfur, and sublimate deposits. Many of the black spots are associated with volcanic craters. A still closer look at the surface of Io was recorded by Voyager 1 at a range of 80,955 miles. The width of the picture represents about 600 miles. As we have mentioned earlier, the reddish and orangish colorations are probably surface deposits of sulfur compounds, salts, and possibly other volcanic sublimates. The dark spot with the irregular radiating pattern near the bottom of the picture may be a volcanic crater with radiating lava flows. Here, Voyager 1 brings us a spectacular image of an enormous volcanic explosion silhouetted against dark space over Io's bright limb, throwing solid material over 100 miles above its crater. Io's volcanic activity appears to be of at least two general kinds: explosive eruptions, such as the one seen here, and lava that flows from vents across the surface. The spacecraft was about 309,000 miles from Io when this image was acquired. Voyager 2 took this picture of Io from a range of 756,000 miles. On the limb of the satellite are two blue volcanic eruption plumes about 70 miles high. A total of 7 plumes have been seen by Voyager 2, all of which were first seen by Voyager 1, which means that they have been actively erupting for at least 4 months. Voyager 1 observed an 8th volcano in March, which had subsided when Voyager 2 arrived in July. Io's is undoubtedly the most active known surface in the solar system, surpassing even the Earth. If a spacecraft were to fly past Earth, it is unlikely that any volcanic activity would be visible despite the great number of volcanoes. Now the Voyager spacecraft leaves giant Jupiter and its fascinating satellites to head ever onward in space to a rendezvous with the mysterious, heavily ringed planet Saturn. Then, if all goes well, the second Voyager to arrive at Saturn will head out even further into space, targeted for an encounter with Uranus. In this program, we have had but a few brief glimpses of the thousands of discoveries made by the Voyager spacecraft on their visits to the largest planet in the solar system. So to the miracle of modern scientific technology, which is the Voyager project, we say, bon voyage, and may you speed safely into the unknown realm of discovery.